Okay, today I will show you the method of designing a pipe system and how to select the pump for the water supply for this project, which is from Patong and Bang Prap. First, we need to visit the USGS website. Okay, so after we visit this data, we will select the area which we are interested in. So in this project, we are interested in Chonburi, so we're gonna click this. Okay, we're gonna click this, and this. After we get the area we are interested in, we will move to select data set, and then we will choose digital elevation, and then SRTM, and we will select SRTM1 arc second global. After we select this, we will press result, and after it generates a bit, we will click this and this. We will get the area that we are interested in, and then we will download this photo. And after we download the photo, we will import the downloaded photo into the QGIS and adjust the display to the normal color. And after we add the map into QGIS program, it will show you something like this. Then you can do the map setting. After that, you need to create a line to lay the pipes. Okay, so this is what you're gonna see. And after that, you need to draw a line along the path where you want to lay your pipes. With each pipes, it need to be 1,000 meters apart, as shown in this image, which is the nodes layout. And after that, we export this image into a PNG file and convert it into a BPM file. And this photo shows the elevation of the nodes as well. And after that, after we export the image, we'll get the coordinate of the north, east, west, and south. And after we insert in the program, it will be something like this. And after we find the x and y coordinate using the sample raster value functions and save them into the Excel. And after that, you need to copy the data from the Excel into an INP file and import the INP file into the Eplanet program.
After you import the BMP file in the Eplanet, you have to open the you have to click on the project and click on the default and set the flow unit into the CMH and the head load formula into the HW and click OK. Next step is you have to import the BMP file that we obtained in the step 2.1 and go to view and click on the dimension, enter the coordinate that we got from the QGIS. Next one is we have to draw the line, pipe, and junction. First, when you add junction, you have to add the elevation in each junction. The elevation that we get from the QGIS is the elevation that is in the real world. Next, we have to enter the water demand in the last junction, which is 7,990 in cubic meter per hour. We have to create a resource at the set total head. Next, we have to create a reservoir at the Patong, as the total head is the elevation of the junction 1, and create a pump. So you have to edit the pump curve. This one is a pump curve. You have to insert a pump curve. You have to adding a pump from the reservoir to the junction 1, and you have to press run to see the result. You have to click on the map and open the pressure. It will show the pressure in different node in each node. If you have the red line, you have to change a pump or change the roughness coefficient from each pipe to make it look real. Next, you can press on the report and open the table click on the column, select elevation, demand, head, select elevation, head and pressure, so we can get the table of elevation, head and pressure that form our design.
By designing using Eplanet 2.2 and QGIS, resulted in the use of two series of 4 parallel pump, each series with a pump of 800S76 type water pump that connected as shown in the figure 12, and to deliver from Klong Pan Thong to Bang Phra Reservoir at the flow rate of 70 million cubic meters per day during the rainy season. As you can see, here is the connected pump in a parallel line, and here is the result of the HGL and EGL with respect to the junction in each node. And after that, here is the graph showing the relationship between HGL and EGL with the ground elevation. For the discussion, during this project we found out that the most critical factor is the elevation of the target and the water supply that was hard to deal with. If the water supply is located lower than the target, more pumps are needed to convey the water. The idea that we use the knowledge of parallel pump system to increase the flow rate by maintaining head loss is important. Next, we trial and error many times to solve the rates pressure head at junction 1. The pressure head exceeds 100 meters, so thus we found the best pump to use is in this project that runs successfully with the moderate pressure head. Thank you for listening.